All right, this is our calculus indefinite integral quiz that we are having tomorrow. I want to, in advance, make a review of this. We have 7 problems. First one is find the indefinite integral. We have the integral of 5 dx. What we're going to do is take that coefficient and move this out front of the integral. And so we have dx, and so we have 5. And the integral of dx, which is d1 dx to the 0 power, we raise x to the 0 power, x to the 1 power, divided by 1. And so we add our constant of integration, c. So that's number 1. Easiest problem of the bunch. Well, almost as easy. Maybe just as easy, problem 2, where we're going to take this -2 coefficient out front. So it's equal to -2 times the integral of x dx. And that is going to be equal to -2 times, the little dot for times, x to the 1 power raised 1 will be 2, and divided by 2. And we have plus c, constant integration. We have 2 over 2, -2 over 2 cancel to equal -1. So we have negative x squared plus c. And there is problem 2. Almost as easy as problem 1. Now we have find the indefinite integral. We have the integral of 5 square root of x dx. What we're going to do is a kind of a two-step deal here. We're going to move this coefficient of 5 out front. The integral of an x, square root of x, is x to the 1/2 power. And when we take this integral, we end up with 5 x to the, we add 1 to 1/2, so that'd be 1 is 2 over 2 plus 1 over 2 is 3 over 2, so we have x to the 3/2 power, and we're dividing by what we bumped up to, which is going to be dividing by 3/2 plus c. We're going to divide by 3/2, so we have 5 x to the power of 3/2, and dividing by a fraction is the same as multiplying by its reciprocal, and we have plus c, which equals 5 times 2 is 10. So we have 10x to the 3/2 power over 3. And plus the constant integration c. And if we wanted to, we call this 10/3 square root of x cubed plus c. Either one of these, I'm pretty okay with either one of these. You can actually take the square root of x and put the cubed on the outside of the square root here. Anyway, so that's problem number 3. Problem number 4, we have, find the indefinite integral. We have the integral of quantity x squared minus 1 over x squared dx. What we'll do for this one is separate into 2 parts, distributing the dx to each term. So we have the integral of x squared dx minus 1 over x squared dx. Oops, I forgot the little integral symbol, didn't I? Minus 1 over dx squared dx. And we're going to now kind of simplify this one on the right. We're going to have integral of x squared dx here, and minus integral of, now this x, 1 over x squared is x to the negative 2 power dx. And this is going to be equal to x squared is going to be x to the 3rd power. And we divide what we bumped up by. And we're going to have minus, we have x to this negative 2 plus 1 is going to be x to the negative 1 power, and we're going to be dividing by negative 1 plus our constant integration c, and what we have is 1/3 x cubed, and we have the negative minus divided by negative 1 is going to end up being plus, and this x squared to this x to the negative 1 power is going to be 1 over x plus our constant integration c. So there we have problem number 4 worked out. Okay, problem number 5. We have the integral of quantity 2x squared minus square root of x over x dx. And what we're going to do is kind of divide this fraction up. So we have the integral of 2x squared over x, and we're going to make this dx minus integral of square root of x over x dx. So we've separated this fraction out. And we're going to simplify here. Let's see, on the one on the left, we're going to have x squared divided by x is just x. And we have that 2 we're going to bring out front. So we have x dx. And then we're going to have minus, well, this is going to be, I'm just going to write the x, square root of x is x to the 1/2 divided by x to the 1 dx. I'm going to, and we have the integral of this. So we're still going to keep our 2 times the integral of x dx. And this one here is going to be minus, well, we have x to the 1/2 power divided by x to the 1 power. So this is going to be x to the negative 1/2 power. And that's going to be times dx. Yes, to the negative 1/2 power. And this is equal to, we're still going, now we're going to integrate. We're going to have 2 times x to the x to the 1st power raised by 1 is going to be x squared over what we raised the power 2, which is 2. And then we're going to have minus negative 1/2 raised by 1 is going to be x to the 1/2 power. And we're going to divide what we bumped up this power 2 is 1/2 plus our constant integration c. And this 2 over 2 cancel, equal 1, so we have x squared and minus x to the 1/2. And when we divide by a fraction, it's the same as multiplying by its reciprocal, so we're going to multiply by 2 over 1 plus our constant integration c. We're going to just bring this down and finish this up. We have x squared and minus, this is going to be 2, and x to the 1/2 power is going to be square root of x plus our constant integration c. So here we have our problem number 5 completed. Now problem number 6. we have the integral of 3t times quantity t minus 2 squared dt. And what we could use a chain rule of integration, or what we call U substitution rather, but that's not going to work too well from the standpoint of when we integrate, that's not going to cancel, and we haven't done that in this class anyway. Let's go ahead and expand out this quantity t minus 2 squared. So we're going to have t minus 2 times quantity t minus 2, which is going to be equal to t squared. And we're going to have minus 2t minus 2t, so we're going to have minus 4t. And then negative 2 times negative 2 is 4. So now we're going to engage in our rewrite just below. We have the integral of, and what I'm going to do for that is, I'm just going to take that coefficient of 3 right out front, since we can multiply that 3 out later. We're going to have t, and this quantity t minus 2 squared is t squared minus 4t plus 4 dt. And when we work this all out, we're going to have 3, we distribute, we have 3 t times t squared is t cubed minus 4t squared plus 4t, and we have dt times all of this. So let's go ahead and separate this thing out now. We're going to have 3 times the integral of t cubed dt minus 3 times the integral of 4 t squared dt plus 3 times the integral of 4t dt. Now, the tricky thing was keeping this 3 outside of each one of these and separately and treating these ones individually with what was left. But we're going to go ahead and kind of combine coefficients outside. So here we have t cubed dt minus, and we're going to take this 4 times this 3, so we have minus 12 integral of t squared dt plus 3 times 4 is 12, the integral of t dt. So now we should be ready to integrate. So the next line we have 3 t cubed raised by 1 is going to be t to the power 4, and we divide by 4, minus 12, we have t squared becomes t cubed, because 2 plus 1 is 3, and we're going to be dividing by the power we bumped up to, which is 3, and then we have plus 12, we have t to the first power, and 1 plus 2 will be squared, so we divide by 2, and now having integrated, we have our constant integration c. And next thing we're going to do is simplify these 3 terms on the left. So we have 3/4 t to the 4th power, and 12 divided by 3 is 4, so we have minus 4 t cubed, and 12 divided by 2 is 6. We have plus 6 t squared plus our constant of integration c, and this will be our answer to problem number 6. Now, problem number 7, we have solved the following differential equation. So we have f double prime of x equals 2x, comma, f prime of 1 equals 3, and f of 2 equals 6. All right, the first thing we need to realize is that f prime of x is going to be equal to the integral of f double prime of x dx. And we are given f double prime of x, which is 2x. So we can continue down below and say that f prime of x is equal to the integral of f double prime of x, which is 2x dx. And we can rewrite this as 2 times the integral of x dx. So f prime of x is equal to integrating. We have 2x, we have x to the 1 power raised by 1 to 2. 1 plus 1 is 2. We get x squared, and we divide by what we raised. So we divide by 2, and plus our constant integration c. And we have a 2 over 2 cancel equal 1. So simplifying, we have f prime of x is equal to x squared plus c. Now, the next thing we're given is this condition, f prime of 1 equals 3. So replacing f prime of x with 3, see, we're replacing f prime of x with 3, and now we're going to replace x with 1. So we have 1 squared plus c. So we have 3 equals 1 plus c, and therefore c is going to be equal to 2. And so having found that our constant integration c, in this case, is 2, we can take our last version of f prime of x equals x squared plus c and get the particular solution, which is, I want to take f prime of x is equal to x squared plus 2. So I'm going to make just an underlining here, meaning that's kind of preliminary answer. Also, this constant integration is 2 below here. Next, we have, we know that, or should know, that f of x is equal to the integral of f prime of x dx. And we are given, we have found out what f prime of x is. Okay, that's this thing right here. So we can replace f prime of x in this equation up here in purple with this x squared plus 2. So I'm going to erase the arrow here. In doing that, we'll say that f of x is equal to the integral of x squared plus 2 dx. And breaking this integral up, we say that f of x is equal to the integral of x squared dx plus 2 times the integral of dx. And integrating, now we're going to have f of x is equal to, we have x squared becomes x to the third power, and we divide by what we bumped up the power to, which is 3, and then for plus 2, we have plus 2 dx becomes x, so plus 2x, plus our new constant integration, here c, not to confuse with this one in red earlier. And so now we have f of x equals x cubed over 3 plus 2x plus c. And I'm going to leave some room below here to write out our equation with c. So we come down here and we see that f of 2 equals 6. So we can set f of x to 6 right here and set this equal to, okay, the x, replacing that with x with 2, we have 2 cubed divided by 3. And we have plus 2, and x again is 2, plus our constant integration, which is now our unknown that we are solving for. So what we have here is we have 6 equals 2 cubed is going to be 2 times 2 times 2, 8 thirds, plus 4, plus c, and we're going to convert everything to thirds. 6 thirds is going to be 18, 6 is going to be 18 thirds. We have 18 thirds equals 8 thirds, plus 4 is going to be 12 thirds, plus c. So we have, I'm going to draw a little arrow here, save a little space. We have 18 thirds equals 20 thirds plus c. And subtracting 20 thirds from both sides, we have c equals negative 2 over 3, negative 2 thirds. And now, solving our differential equation, c equals negative 2 thirds, we're going to come right back up here. Let's see, we left some space here. No, I didn't leave enough space. So I'll try to write real small. Our particular solution is, I'll write this in blue. F of x is equal to 1/3 x cubed plus 2x minus our constant integration, which is 2 thirds. So this is our final solved differential equation right here. So anyway, that's our quiz. I hope it's been helpful to you. I hope you did pretty well. And if not, it's always a preparation for the future. Thank you for viewing.